Hello, I am Manrique and I will be discussing to you what is a pigeonhole sort. First, pigeonhole sort is a sorting algorithm that works best when the number of elements and the range of possible key values are about the same. Imagine you have several items that need to be placed into boxes, or in this case, the pigeonholes, based on their values. The algorithm first finds the range of the data, then creates an array of empty pigeonholes, one for each possible key value. Each element from the list is placed into its corresponding pigeonhole based on its key. After that, the algorithm collects the elements from the pigeonholes in order, which results in a sorted list. Pigeonhole sort has a time complexity of O in the parentheses n plus n, where n is the number of elements and n is the range of possible key values. Because of this, it's most efficient when n and n are roughly equal. Essentially, it's a simple and direct sorting method, but it's not always practical for data with large range of values. A trivia, the term pigeonhole comes from small cubicles that were once used to sort letters delivered by pigeons. It also refers to categorizing things in a specific or restrictive manner.
Good morning everyone, my name is Ace. I'll be showing you the visualization of the pigeonhole sorting algorithm. So, given the input 7, 6, 5, 6, 9, 10, we also have the pigeonhole boxes below. So to calculate the number of pigeonholes, we use the formula size is equals to max minus min plus 1. Max is 10, the min is 5, so 10 minus 5 plus 1 is 6, so we have 6 pigeonhole boxes. So next, we place each number in its pigeonhole using the formula index is equals to element minus min. So we'll show you the visualization. So 7 is placed in 2 and 6 is placed in 1. So why 7 is placed in 2? So the formula is element minus min. So 7 minus the min, which is 5, will get 2. So it is placed in 2. So 6, why is 6 placed in 1? Because 6 is placed in 1 because 6 minus 5 is 1. So let's proceed. So 5 is placed in 0 because 5 minus 5 is 0. So we have a duplicate 6 minus 5, which is 1. So it's placed in 6. It's placed in 1 as well. So the remaining two numbers, 9 and 10. So they are placed in 4 because 9 minus 5, which is 4. 10 minus 5 is 5. Or each number goes into the box corresponding to its value. So now we collect numbers from the pigeonhole in order from index 0 to 5. So wait. So collecting 5 from pigeonhole, which is 5, pigeonhole 0, 5, pigeonhole 1, which you will have 2 duplicates, 6, pigeonhole 2 we have 7, pigeonhole 3 we have empty, pigeonhole 4 we have 9, and pigeonhole 5, 10, and it will be sorted. This rebuilds the array in a sorted order. So that's the visualization of the pigeonhole sorting algorithm. Thank you.
So, good day, sir. So my name is Francis, and I'll be explaining the time complexity and the efficiency of the pigeonhole sort algorithm. So, in general, the time complexity tells us how the running time of an algorithm increases as the input size grows. So for pigeonhole sort, its performance actually depends on both the number of elements and the range of values in the array. So here we have the table here, and then on my right we have n, the big N, which is equal to the range of possible values, and the smaller n, which represents the number of elements. So I'm going to go through the steps on how we got the time complexity, and explain how and why it is the efficiency of the algorithm. So, also, by the way, the space complexity of the algorithm is also O of n plus the range, because we allocate extra memory for the pigeonholes. So here's how we arrive at the O of n plus the range complexity from the steps in the pseudocode. So for the step 1 is finding the minimum and the maximum of the array. Its time complexity is O of n. Why? Because we scan the array once to find the minimum and the maximum, and that only takes one, so it's O of n. And for the step 2, we initialize the pigeonholes or an array, which is actually taken from adding the minimum and the maximum and adding 1. So we initialize the pigeonholes, and since there are a range number of them, that's O of n, the bigger N, which is the range of possible values. And next is step 3, is we count each of the elements. So the process here is we go through the array again to count each element's frequency. So that is another O of n, which is the number of elements. And then finally, for the step 4, we rebuild the sorted array by iterating through each hole and placing elements back. So the total work done here is proportional to both n and the range, giving us an O of n plus range. So when we add them all up, we get an O of n plus range overall. This shows why pigeonhole sort is great for small, tightly ranged data, but not for large or wide-ranging datasets. So to summarize, pigeonhole performs linearly when the range is close to the number of elements, but as the range grows much larger, its efficiency drops both in time and in space. So for example, if we have the maximum and the minimum being so far apart from each other, like for example, we have the minimum as 2 and the maximum as 8,000, then it would generally do 8,000 pigeonholes, which will take longer. So its efficiency depends on how close it is from the number of elements and the range. So the smaller the difference between them is, the better the algorithm will perform. So that is all for the efficiency of the pigeonhole sort. Thank you.
Hello, good morning everyone, and I am Mark, and I'll be explaining the pseudocode for the pigeonhole sort. So first of all, we need to initialize a function, and input our array to the function as an argument. And after we're done with that, we can move on to the step 1, which is finding the minimum and maximum, and also evaluate the range. So we need the maximum and minimum to get the value of range. So first of all, maximum, it means that it is the largest value in the array. For example, in an array of 1, 2, and 3, it means that it will get 3 because 3 is the largest value in the array. So same with minimum, but minimum is the opposite of a maximum, which is the smallest value in the array, found in the array. So after that, to get the value of range, we can just subtract minimum to maximum and add 1. So after we're done with getting the values for our minimum, maximum, and range, we can go on to the step 2, which is to initialize our holes. This sorting algorithm is actually based on a math. I think it is a theorem. I don't know if it is theorem or basta. It is it's a principle, the pigeonhole principle, where if there are more let's say elements than containers, it means that at least one of the containers contains one or more elements or values. So we move on to the step 2. So initialize holes. So holes range with the parameters with arguments range and 0. Range means that the range the length of the holes is equal to range, and the second argument means that all of the indices in the holes is initialized to 0, or all elements is initialized to 0. All the elements so that's it, and I'll be moving on to the part 2 of the pseudocodes in a quick second. Hello again, everyone, and this is the part 2 of our explanation of our pigeonhole sort pseudocode. So now we'll be starting with the step 3. So now in the step 3 we'll be counting each element in the array. So we'll be counting how many instances are there. For example, we have arrays with 2 of the same elements, for example, or duplicates. We have 2 5s in an array of like 5 elements. Like there's 5 5 4 10 8, something like that. So we'll be counting them and putting them in the respective holes. So in the first line we'll be having a for loop, so for each element in array, and then inside we have the int element receives the value of the array at that particular index. So, and then in the next line, incrementing the holes. It means that once we found a value, we'll be incrementing it to its respective hole. So the index of that value is determined through the value of element minus the minimum. So for example, 5, we have the element 5 and our minimum is 4, so it means 5 minus 4 1. So then it will be stored at index 1. So we'll be incrementing the index 1 by 1. So now, for example, there's 2 5s in the array, so another 5 minus the minimum, which is 4, and then we add again add 1 again to that specific index in that whole list. So it means that index 0 has now the value of 2. So it means that there's 2 elements stored in the whole 0, or I mean 1. So if we want to store a value in the whole 0, it means that our minimum is 4. So if we put 4 in the element and minus the minimum, it will become 0. So then 4 will be stored in the index 0, and will be incrementing, not really stored. The 4 is not really stored in the holes, but we are counting them, like counting how many 4s are there in the 0. So incrementing 1 will be incrementing 1 in the 0. So now that we're done with step 3, let's go to the step 4. We'll now be rebuilding the sorted array. So first of all, we'll be initializing the index at 0, so it starts at 0. Now in the second line, we'll be having a for loop again for each element in range. So, and another array nested, like not array, another loop. So there's